So these are the essential mother functions for Algebra 2 in the great state of Tennessee. This will be a little different depending on what state you're in, but in the state of Tennessee, like, we don't talk about sine and cosine and tangent. We don't talk about trig anymore in Algebra 2, so those are not going to be on there. But we talk about pretty much everything else. Now, the first thing I'm actually going to do is not a mother function, but it's one of those that's critical to understanding algebra because it's often the axis of symmetry. It's those type of equations, the x equals. So the first one I'm going to talk about is not a mother function, okay? Because it's not a function, period. But it's x equals a constant. Now, x equals a constant is a vertical line. Okay, so I'm just going to go out on the x-axis and I'm going to mark a place C and I'm going to draw a vertical line. Now, I make my kids plot a point and they call that point C0. I also make my kids understand the domain and range of this thing. I really put a stress on domain early on. We spent like the first 2 weeks doing daily calisthenics on what these graphs look like. Vertical line, absolute value, x squared. We do all that stuff on a regular basis first couple weeks of class. The domain of this thing is just the singular element C. That's all it is. It just contains a C, nothing more. The range of this thing, the y values, it falls forever, rises forever. Negative infinity to infinity. All right, next one that I make my kids memorize is a mother function, and it's these, well, it is and it isn't. The next thing I make kids memorize is this one, the y equals the constant, the horizontal line. So we pick a place on the x-axis, or the y-axis, we call it C, and then we draw in a horizontal line. I make my kids plot a point. If they don't plot a point, I take off. The x-coordinate here is 0, and the y-coordinate is C. And I do that because there's a lot of kids who really struggle, even getting to Algebra 2, they still struggle with which one's x and which one's y, so make them do it. The more practice they get, the more likely they'll remember it. Domain, left forever, right forever. That's a negative infinity to positive infinity concept. The range is simply the element C, whatever that C value would happen to be. So there's the first two that I do with my children. And, you know, on day one, we go over all the mother function graphs. On day 2, they take a quiz. And on day 3, they take a quiz. And on day 4, they take a quiz. And on day 5, they take a quiz. It's just kind of how it goes in the beginning as I try to get these graphs ingrained in their head. It's hard on me. Way harder on me than, believe it or not, it is on them. The next thing that would be on their little mother function quiz would be the slant, y equals x. And I don't make them do a table for that, but, you know, when I'm going over it, I do. We have x, and it's literally y equals x. So if x is -1, x is also -1. If x is 0, the y value would be 0. So this is y, right? It was x equals y equals x, this is y. And if x was 1, this would be 1. And I don't make them draw the table. I usually only say, give me 2 points. You know, you got to make the kids plot the points, otherwise they draw something else. I see an alarming number of kids who just draw that, and I count that wrong. It's the slant. And yeah, that is a mom function, because all lines look like that, with the exception of the horizontal and the vertical. Its domain is quite simple. It runs left and right forever, so negative infinity to positive infinity. Its range is also the same thing. It falls forever and rises forever. All right, there's y equals x. Next up would be the absolute value. And this is such an easy graph because value starts with a v. We're going to draw a v. That's what it looks like. You need a little table here. X, absolute value of x. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. 3 key points. That's how most things are taught in algebra. 3 key points. So we're going to contain 0, 0, 1, -1, +1, and +1, +1. And we're going to draw a v. That's 4, but wait, there's more. There's a whole lot more. If you're an Algebra 2 kid and you've already had my class, you know there's more. There's always more. Always. There's a reason that pretty much every graduation speech talks about surviving Milbrath, because that's what you do. You don't thrive, you survive. I'm the only one thriving. I literally live off your pain, right? Wouldn't that be funny? All right, so after this one, the next one that I would put on your quiz would be y equals x squared. Whoa, it's a big deal in algebra. That's a quadratic, man. The parabola, it's huge in algebra. It's huge. It's probably 50% of the course is talking about something with a 2 as an exponent. Anywho, if you take a negative 1 times a negative 1, because we're squaring, you get 1 back. You square a 0, you get a 0. Square a 1, you get a 1. It's got the same exact points as the absolute value function. Ooh. I haven't been talking about, did I do domain and range on absolute value? I don't believe I did. Let me go back to absolute value real quick. I don't believe I talked about the domain and range of that thing. I'm in such a hurry. I got all excited about the quadratic. Domain, negative infinity to infinity. The range, the lowest y value is 0. There's a solid dot on your graph. You use a bracket. It rises on either side of the v to infinity. Now, back to the one I was doing. Same 3 points as absolute value, negative 1, positive 1, 0, 0, and 1, 1, except this one has curvature. It is a parabola, and it looks like that. And it has the exact same domain and range as absolute value. The domain runs left forever, runs right forever. Negative infinity to infinity. The range, the lowest y value is there. Y is 0 there, and then it rises on the other side to infinity. All right, so after x squared, I would do its inverse, and its inverse is going to be the square root function. And on my quizzes, I have these written out 2 different ways. And I might be using f of x, I'm not sure. But I would have, let's do f of x just because. F of x equals the square root of x or x to the 1/2. I do that all the time. Even early on, I introduce exponents in Algebra 2 because kids struggle with it. So we just need to keep seeing it and keep seeing it and keep seeing it. But believe it or not, the smallest thing that you can take the square root of and be real is 0. And the square root of 0 is 0. The next smallest thing you take the square root of and be real is 1. And the square root of 1 is still 1. And after that, it's a 4. And the square root of 4 is a 2. I only make kids memorize 2 points, but 4 points gives you the curvature of the arm. And that's what this one is. We have 0, 0, we have 1, 1, and then we have 4, 2. And I call this the arm. It's part of our calisthenics. It's the arm. Its domain, its low x value is 0. The bracket, because that was a nice solid dot, runs right forever. Its range is also the same thing. The low y value is there at 0, and it rises forever. All right, so there's actually still quite a bit more to go. At least 5 to go. Like, there's a lot of other functions that I make kids memorize first week of school. There's a lot of them. Next thing would be f of x equals x cubed. That's the next one that I make my kids do. And again, we learn all this stuff early in the year, you know, when they don't have their laptops and they can't be on YouTube watching stuff. So this is stuff we do very early in the year. I teach 3 key points. If you cube a negative 1, you get a 1. If you cube a 0, you get a 0. And if you cube a a positive 1, you get a 1 back. Cube a negative 1, you still get a negative 1. If you cube a 0, you get a 0. You cube a 1, you get a 1. Now x cubed starts low and ends high. And that's also something we learn. We learn what's called end behavior, which is also going to be in this video. Because end behavior is a big deal. It really is. You don't really get good at math until you understand graphs. And understanding graphs is based on memorizing the mother functions. That's where it starts. You got to connect those dots somehow. This isn't we don't just jump into synthesizing things without memorizing things. The domain of this thing runs left and right forever. Negative infinity to infinity, infinity and beyond. The range falls forever, rises forever. Negative infinity to infinity and beyond. After x cubed, the next thing that would be done, that was choice 7, right? The 8th thing that would be on this quiz would be its inverse, the cubic root of x, or more affectionately written as x to the 1/3 power. That would be the very next one. I don't know what happened to my little pink marker. There it is. It's actually got the same 3 points, but its shape is different. It's the inverse. If you take the cubic root of -1, you still get a -1. If you take the cubic root of 0, you still get a 0. You take the cubic root of 1, you still get a 1. So it's got the same 3 points. But the difference is it's horizontal as opposed to vertical. Horizontal as opposed to vertical. It has the same domain and range too. It is running left forever, and it is running right forever. Additionally, it is falling forever as you move left, and it is rising forever as you move right. So I'm trying to think of what's next. I think what's next is going to be an exponential function. Feels like I've covered all the biggies up to exponentials. So the 9th one is going to be an exponential function. And I'm going to start off with the natural exponential function, e to the x. So the 9th one, f of x equals e to the x. Make a little table here. X, e to the x. If you let x be 0, this would be e to the 0, and anything to the 0th power is 1. If you let x be 1, we'd have e to the 1st, which is just e, which is about 2.72. Make your kids memorize what e to the x looks like, because it'll help them just memorize what exponential growth looks like in general, and it's not a hard one to do. So we contain 0, 1, which all exponentials contain unless you've done a transformation. And then we contain 1 and something close to 2.72. Now, we have a horizontal asymptote on this graph. So we're going to talk about that too. We do have a horizontal asymptote. Your domain, it runs left and right forever. Your range, this thing gets really close to a y value of 0. Doesn't quite hit it, so parentheses. And then it rises forever as it moves right. It's literally the definition of exponential growth. And since it has one, we're going to talk about it. It's got a horizontal asymptote. That's what HA is for. I don't like to write horizontal asymptote over and over and over. So I just write ha. The horizontal asymptote is at y equals 0. The horizontal asymptote is the line that this graph will never, ever, ever cross, because it is impossible to use exponents to create negative numbers. And there you go. Next one, the 10th one. Y equals ab to the x. Tables, good old boring tables. That's where it's at. Let's let x be 0. This would give us a times b to the 0, and anything to the 0th power is a 1, so we just get a back. Let's let x be 1. This would be a b to the 1st. So it's just ab. Interesting, huh? So if x is 0, I contain a point called 0, comma a. And if x is 1, I contain the point 1, comma ab. And by default, we make it look like growth. Now, what's its domain? Its domain is negative infinity to positive infinity. It's an exponential growth function. Its range gets close to 0, and then rises to infinity. And this one has the same horizontal asymptote as the last time. Last one did is that y equals 0. Don't worry, I'm almost done with these mom functions. So the last essential mother function for Tennessee Algebra 2, not necessarily New York Algebra 2 or California Algebra 2, is going to be the logarithm. That's the last essential, is the logarithm. So let's do the logarithm. Logarithms look like R's. Now, a lot of classes in this country use a TI-84. A TI-84 does not graph logarithms properly. Desmos is graphing logarithms properly, and that's fairly, it seems like that's recent. That or the Mandela effect is getting to me. It seems like maybe at one point in time Desmos did not graph logarithms properly, but I checked it the other day and it is. But again, that could also be the butterfly effect or Mandela effect kicking in. Let's see, that was Ix, that was X, this is Xi, the logarithm. F of X equals log base B of X. And let's make that an A. Log base B of A. Now, some things about logarithms that help some of this make sense. A log base B of B is 1. Okay? A log base B of B is 1. And a log base B of 1 is 0. So that's kind of how these things work to some degree. I kind of lost my train of thought there for a second. All right, so sorry I lost my train of thought there. Just got off. Now, I changed that back to an X because it just makes more sense. It's kind of a funny looking table. But if we let X be 1, we're going to get a 0 back. And if we let X be B, we're going to get a 1 back. And those are my key points. Now, this is a logarithm. Logarithms, they look like R's. That's the big deal. They look like the letter R. And unless a transformation's happened, a logarithm's going to contain 1, 0. And that's the most important point that kids actually get. It's not the second one, it's the first one. But it'd be really cool if they got the second one too, which is at B, 1, because this is an idea that really needs to be memorized. It really does need to be memorized. Now, the logarithms are the inverses of the exponential functions. The exponential functions could not cross the x-axis, therefore logarithms cannot cross the y-axis. So this one actually has what's called a vertical asymptote happening. And there's that form, that vertical line. That's why I talked about it's on my mother function quizzes, even though it's not even a function. Because of what it is, it's axis of symmetry, it's vertical asymptotes. It's important that kids know what vertical equations look like and how they're written. The domain of the logarithm, the smallest x value is something ridiculously close to 0, and then it runs right forever. The range, we fall forever and we rise slowly forever, negative infinity to infinity. And we have a vertical asymptote. Logarithms are really about the only place in Algebra 2 anymore that we talk about vertical asymptotes. It's kind of a sham what Tennessee has turned Algebra 2 into. If you're from the Department of Education, I'm not, that's what you've done. You've murdered Algebra 2. You took out all the fun stuff, all the difficult stuff. And I really wish you'd put it back in. Because Algebra 2 is supposed to be a class that preps our STEM majors. It's not supposed to be a class for everyone. Make it what it's supposed to be. Quit dumbing it down. Get kids a different math class if they ain't college bound. Let me teach Algebra 2 the way it's meant to be taught. Anyways, we have a vertical asymptote at x equals 0. And there's your logarithm. And that should be the essential mother functions for Algebra 2 based on the current Tennessee state standards. If you're in a different state, there's a little more. They'll probably have sine and cosine and tangent included, and probably 1 over x, and that should cover all of them. What we still do in pre-calc is going to be, for a lot of states, what you do in Algebra 2. All right. I hope you enjoyed your lesson on mother functions. Memorize those things. It'll make Algebra 2 make more sense. It'll make it easier to do, and you might get some good grades, right?